Okay, now let's do an example here. So let's say we are given an area as in the picture here. So we need to find the center of this area. Okay, the center position means that somewhere here lah, center. And then the coordinate of the location is x bar and y bar. So you need to find the value of x bar and y bar. Okay. So you can use the 4 steps that we already discussed in a lecture video. Okay. So apply all the steps to solve this question. Okay. The first one is to choose an appropriate differential element. Differential of area at a general point xy. Okay, so because we need to find the area of the shape here, so you need to do the integration. Okay, if we integrate the equation here, let's say we do the integration of the area, right? So using dA, what is dA? dA is actually an x of a function of we actually integrate the function of y with the function of differential of the x. Okay, so which means that we integrate this function to the changing of x here. Okay, so it will become like this. Okay, so this is your shape, and then you integrate this curve here with the changing of x. Let's say from x0 to x1. Okay, so x0 to x1 is a changing of x. Okay, so which means that the difference of x, which is differential of the x. Okay, so this type of integration, we call it as a vertical rectangle element. Okay, because we are using the vertical rectangle. Okay, so the vertical rectangle will, of course, after the integration will develop until it approaching the shape of the curve of the shape to get the whole area. Okay, so you need to decide whether you want to use the function of y in term of x or x in term of y. For example, y equals to x squared plus 1. Okay, so this one you need to do you need to use the vertical rectangle element like this one. Okay, if let's say you are using the function of x in terms of y squared plus 1, let's say, so you need to use the horizontal rectangle element. Okay, so that's the first step you need to apply when you want to do such analysis. Okay, so the first one is to decide whether you want to use the vertical or horizontal rectangle element. Okay, in this case, the solution here is using the vertical rectangle strip. Okay, because it is more easy to solve. Because in this case it is already given the function is y equals to 1 minus x squared. So we are using the vertical one lah. Okay. Okay, let's say if you want, if you integrate the y function y dx, so which means that you are using the changing of x. So this is a rectangle, vertical element lah. Okay, because it is changing of x from 0 to 1. Okay, so if you are using integration of x, so the changing is the y-axis lah. So your when using this, so you need to use horizontal rectangle element, this one. Okay, which means that the changing is from y1 to next y lah, yn. So now you have decided to choose the vertical rectangle element. So this one, so the function is the integration function is you are using this formula lah. Okay, and then you already do this step and this step, and then the third step is to determine coordinate of x bar and y bar in terms of general point. Okay, so because you are using the vertical rectangle element, if I can zoom it. Okay, so the rectangle element is like this. Okay, so your coordinate must be somewhere here. Okay, somewhere here lah. Okay, so the coordinate for x is so okay, so I remove what is not necessary. So let's redraw it again to make it more clear. So if we have a function and then we decide to use the vertical rectangle element, okay, so we want to generalize the coordinate of x bar and y bar. So for x bar, let's say we assume the coordinate of the center of the gravity of the shape is in this location. So which means that for the x-axis, the x bar will be is x. Whatever the value here, we need to calculate later. Okay. And then for y bar is actually half of the triangle here. Okay. So the y bar is equals to half of whatever y value here, y over 2 lah. Okay, so you already do the step 3 and then we go for step 4. Okay, we want to solve the questions. Okay, so express all the variable and integral limit in the formula using either x or y depending on whether the differential element is in terms of dx or dy. So in this case, we are using the integration of in terms of dy, differential of x, okay, respectively, and integrate. Okay, so we start to do the integration to find the x bar and y bar. Okay, so we remove all that is not necessary. Okay, you already decide the function which is you want to use the function of dx. Okay, it's y dx, which means that when you want to find the x bar and y bar, which is the coordinate or location of the center of this shape, so x bar is equals to the general formula for find the x bar we already discussed previously in the previous lecture. This is the integral of x x dA over the integral of dA. Okay. Same goes to this one. Y bar is equals to integral of y dA over integral of dA. Okay. So the dA you already decide to use the function of dx, which means that dA is equals to y dx. Okay. So just substitute into these equations. So it will become x y dx over the integral of y dx. Okay. And then you already generalize the coordinate for x. Okay, which means x bar is equals to x. Okay, and then this is quite difficult. And then for y bar is equals to y over 2. And then your function of y, your equation of y is to the function of x is equals to 9 minus x2, x squared. Okay, so substitute all the information here into the equation here, which means that this is equals to integration of x. Substitute this y with the equation here. Okay, which means that 9 minus x squared dx, okay, over integral of y. Substitute with this equation, 9 minus x squared dx. Okay, so we do the integrations because we are using the vertical rectangle element. Okay, just like this. This is your shape. So the vertical one. Okay, so this is a changing of x from certain x to certain x. So because we want to do the integration, so we want to know the whole area. So from 0 to the size is 3 feet. So from 0 to 3. Okay. So we need to integrate with using the function of x from 0 to 3. Okay, this one also 0 to 3. Okay, after that, so solve this integration and solve the equation. Okay, first is to expand this equation, become 9x minus x s cubed. Okay, and then dx. Okay, 9 minus x squared dx. Okay, and then do the integration from 0 to 3. 0 to 3, 0 to 3. So this one become 9x. To remove the dx, this dx, you need to multiply with the x. So x with x squared over 2. Okay, please recall back how to do the integration. This you already learned in maybe in a secondary school, and in engineering calculus also you do a lot of integration calculation. Okay, and then this one, when you remove the dx into the x, you need to add up the power here. 3 become 4, and then over the number here 4. Okay, so we want to integrate from 0 to 3. Okay, same to the for the denominator. Okay, so 9x minus x cubed over 3. Okay, this is also same to integrate from 0 to 3. Okay, so this one you need to solve 9 squared over 2 minus 3 to the power of 4 minus 9, 0. This one is 0. 4. Okay, and solve for this, you will get, but let's do for the denominator also. So 9 3 minus cube over 3 minus this one is 0. Okay, this one also 0. If can, don't solve first, just write all the equation here to get the right numbers before you simply round up the decimal point. Okay, so after you calculate, make sure you will get the answer is equal to 1.13 feet. So now you already solve the x bar, so you already know the location of for x bar, and now we do the same thing for y bar. So your x bar here is equal to 1.13 feet. Okay, so now let's do for y bar. This one is equals to integration of y dA. You already decide to take the changing of the x because you choose the vertical rectangular strip. So for vertical rectangular element, we need to choose the differential of x. So this one is become dA is equals to this one. So y dx over integration of y dx. Okay, so substitute all the equation of y with this equation. So it will this will become y is 9 minus x squared. 9 minus x squared. So this one is dx over of 9 minus x squared dx. Okay, before that I forgot, before you change y into these equations, we already generalized the y here is actually is a half of y bar. So that's mean this y here must be any y, or we can write here y is equals to y over 2. So any y must we must take the half of the y. Okay, because based on this rectangle, the x is any value of x, but the y here we cannot simply take y, because if we take y at any location of the rectangle here of the changing of x here, so it will take the maximum value. Okay, so because this is the center, so it must be half of the the value of y here. Okay, so any changes must be half of the y, so y over 2. So this one is also y, we must change the y here with y over 2, half of the y. So this become, but before that, please remember that this is particularly for this y only. This is a y bar also. So the y bar, we already generalize it, become the half y. So this y bar will become y over 2, then y dx, y dx. So please please don't confuse with the y over here. Okay, this is only for this one. Okay, so this one have over 2 over here. Okay, so this equation becomes like this. We can any numbers we can put outside the integration, so it's become 1 over 2. Okay, 9x 9 minus x squared dx. Okay, integration of 9 minus x squared dx. And then expand the equation first. For the numerator become 9x2 and then 81, and then 81 minus 9x2 minus x4. Okay, please do your own for this one, and then make sure that you will get the answer is equals to 3.6 feet. So your x bar is equals to 1.13 feet, and your y bar is equals to 3.6 feet. Okay, looking at this picture, so your x bar is around, so from here to here is 3 feet. So 1, 2, 3. Okay, so somewhere around here lah, 1.3. This is your x bar, and then your y bar is 3.6. Okay, this one is 9 feet, so we can divide into 3. 3.6 is somewhere here lah. Okay, so the meeting point here is the center of this of this shape. Okay, so you already get the location of your centroid of the gravity or the center of mass for this shape, which is at the coordinate of x bar y bar 1.13, 3.6. Okay, so you can put your gravitational force over here. Okay, this is your gravitational force. Okay, at the center of the gravity of the shape. Okay, that's it. Thank you.